JWST, or Webb for short, is the first biggest telescope to rocket past Earth's atmosphere since the Hubble Space Telescope, which was launched in 1990. Webb, a collaboration between NASA, the European Space Agency, and the Canadian Space Agency, is 6 times bigger and 100 times more stronger than its ancestor. In today's video, we are taking an inside look at NASA's new $10 billion James Webb Space Telescope. Location and orbit. JWST operates in a halo orbit, rolling around a point in space known as the Sun-Earth L2 Lagrange point, which is almost 1.5 million kilometers beyond Earth's orbit around the Sun. Its real position ranges between 250,000 kilometers and 832,000 kilometers from L2 as it orbits, keeping it out of both Earth and Moon's shadow. Objects near this Sun-Earth L2 point can orbit the Sun in synchrony with the Earth, allowing the telescope to stay at a constant distance with constant orientation of its unique sun shield and equipment bus toward the Sun, Earth, and Moon. Combined with its large shadow-avoiding orbit, the telescope can block incoming heat and light from all 3 of these bodies and prevent the smallest changes of temperature from Earth and Moon shadows that would affect the structure. However, it still maintains steady solar power and Earth communications on its sun-facing side. Sun shield protection. The shielding strengthens a strong temperature for the structures on the dark side, which is important for maintaining detailed alignment of the primary mirror segments in space. The 5-layer sun shield's layer is as thin as a human hair, which is designed from Captain E. It is a commercially available polyimide film from DuPont with membranes specifically coated with aluminum on both sides and a layer of doped silicon on the sun-facing side of the 2 hottest layers to reflect the sun's heat back into space. Because of the sun shield, JWST does not have an endless field of regard at any given time. The telescope can see 40% of the sky from one position and can see all of the sky over a period of 6 months. It is the amount of time that it takes to complete half its orbit around the sun. Optics. JWST is designed especially for near-infrared astronomy, but can also see orange and red light, as well as the mid-infrared region. Counting on the instrument, JWST's primary mirror is a gold-coated beryllium reflector. If it was built as a single large mirror, this would have been extremely big for existing launch vehicles. The mirror is composed of 18 hexagonal segments, which unfolded after the telescope was launched. Image plane wavefront sensing through phase retrieval is used to place the mirror segments in the correct location by using precise micromotors. Next to this initial configuration, they only need a few updates every few days to maintain optimal focus. The Webb telescope uses 132 small motors to position and adjust the optics, as there are only few environmental disturbances of a telescope in space. JWST's optical design is a 3-mirror anastigmat, which makes use of curved secondary and tertiary mirrors to provide pictures that are free from optical freaks over a wide field. The secondary mirror is 0.74 m in diameter. In addition, there is an excellent steering mirror, which can adjust its position many times to give image stabilization. The primary mirror segments are dug at the rear in a honeycomb pattern to reduce weight. Spacecraft bus. The spacecraft bus is the major support component of the James Webb Space Telescope, which hosts a bunch of computing, communication, electric power, propulsion, and structural parts. Along with the sun shield, it shapes the spacecraft element of the Space Telescope. The other 2 major components of JWST are the Integrated Science Instrument Module and the Optical Telescope element. The structure of the spacecraft bus has a mass of 770 pounds and must support the 13,700-pound Space Telescope. It is made of graphite composite material and was assembled in California. The spacecraft bus can rotate the telescope with a pointing accuracy of 1 arc second and isolates vibration down to 2 milliseconds. In the main computing, memory storage, and communications equipment, the processor and software direct data to the instrument's solid-state memory core and to the radio system, which can send back data to Earth and accept commands. The computer also monitors the pointing of the spacecraft, taking in sensor data from the gyroscopes and star tracker and sending commands to the thrusters. Servicing. JWST is not planned to be repaired in space. A crewed mission to repair or upgrade the observatory is not possible, and according to NASA Associate Administrator Thomas Zurbuchen, an unscrewed remote mission was found to be beyond current technology at the time JWST was designed. During the long JWST testing period, NASA administrators cited the idea of a servicing mission, but no plans were confirmed. Since its successful launch, NASA have stated that specified accommodation was made to promote future servicing missions. This comprises precise guidance markers in the shape of crosses on the surface of JWST for use by remote servicing missions, as well as refillable fuel tanks, removable heat protectors, and handy attachment points. What are your thoughts on NASA's $10 billion James Webb Space Telescope? Tell us in the comments section below. Well, that's it for today. Don't forget to hit the red subscribe button so that you never miss out on any of our videos. See you soon. Thanks for watching.